Afternoon everyone, I am Anoop Singh and today I will be covering programming concept for geocomputation and a brief introduction to R. So first we will start with geocomputation, what is geocomputation, and then we will move to programming part in which I will try to introduce basics of R and try to do some geocomputation through R. So content will be like this for today's session. First I will be covering geocomputation, and then about geospatial data. Then why we need R for geocomputation. And after that installation part, how you can install R and R Studio. Next is data types. After that I will cover functions of R and packages required for geospatial analysis. And in the end I will do some hands-on using geospatial analysis through R. So we'll start now. So first, what is geocomputation? So geocomputation is a new field and it is like a study of intersections of geography and computation. So basically what we are doing here, we are trying to do some geospatial analysis using high-end computations so that we can do some scientific research. It can be like regarded as the applications of the computational science paradigm to study a wide range of problems in geographical and earth science context. So main approach for geocomputation is our approach should be like scientific temperament, like we should focus on scientific study for geocomputation. So it is a term coined in recently like 1997. Earlier we are using geoprocessing for the same. So next part is what is geospatial data. So geospatial data is any information that describes objects, event or other features with location. It's maybe on surface of earth. So any location on the surface of earth having data of its location will be called a geospatial data. So geospatial data combines location information, attribute information and temporal information. Location information can be of lat long or earth-centric coordinates, and attribute information like non-special information, which can be, suppose you are going to ATM, so name of the bank of that name of that ATM will be a attribute information, and temporal information will be like occurrence of some occurrence of that information, like what is the frequency of that information. So in geospatial data of location specific can be divided into two parts: vector data and next is raster data. So vector data is described as a graphical representation of the real world. So any real world information can be represented using vector data. It can be further classified into three types. First one is points, next is lines or polylines, and next is polygons. So points, suppose you have a save file of containing all the ATM information in within a city. So it will be represented just lat and long, so it will be called as a point data. Lines can be like network of railway network or roads, that can be represented using lines. Polygon, suppose you want to represent the area of any district or perimeter of any districts or any block or any state, so for that we can use polygon. And next part is like how it is represented. So here it has shown like point will be dots xy, and if we combine 2 points it will become a line, so it can contain more points also. And next is polylines, so it will contain many lines, but first point and last point will be not same in polylines. In polygon, first starting point and last point will be always the same, that's why it is called polygon, and minimum 3 points is required to construct a polygon. Vector data is generally represented in save files, so sometimes it is also called as save files because generally it is stored in .save files. Next is raster data. Raster data is represented in a grid form of pixels. Suppose you are taking any image through satellites of any particular location of earth, so that image will contains pixels, and each pixel will have a value, that is called raster data. So it can be represented in two formats, like TIFF, JPEG. Other formats are also there, but these two are very common. So suppose here any particular location we are taking, so a grid will come, and in grid each pixels will have value. It can be like intensity or reflection of that surface. So these things it will represent. like it can represent like elevation also of that surface. So through these we can these things we can represent in raster data. It will be continuous data, and raster data can be in multi-bands also. So suppose you are representing a multi-band data using RGB. So here each band will contains different information. Like suppose we are taking an image of earth through a satellites. So what is the content of what is reflected energy of red band and green band and blue bands, that can be represented in multi-band raster data. Like for suppose satellite is there, in that I think 8 bands are there. So this way we can represent multi-band raster data in a single file. And there is something called FCC, fast composite color also. So in that what we are doing, we are representing green as blue and red as green, and near infrared we are representing as red. Generally for vegetation we use near infrared. So next we'll move to R. These parts what we have described here, like vector and raster data, we will try to do some analysis on this data using R later part of the course. So what is R? R is an open source programming language, and it is mainly used for data analysis and statistical computing, and also it is getting popular for geospatial analysis. So first I will cover brief history of R. It is modeled on S and S+ language developed at AT and NT labs in late 1980s. Our project was started by Robert Gentleman and Ross Ihaka, Department of Statistics at Auckland University. Currently, it is a open source, and volunteers of developer are contributing it, and like it has more than like 10,000 packages right now. So it's very popular. And next part is why we are using R for geocomputation. So major advantages of R for using geocomputation is, like, first, it is a multi-platform. So like R you can use for Linux also, for Windows also, for Mac OS also, and it is an open source language, so anybody can use it. It's free, and it's a wide. It has already I've explained. It has wide range of packages. So if you want to use it, so many packages are available. So you no need to do all the programming. Already some packages will be there, like for plotting, ggplot2 is there. For raster data analysis, raster package is there. So like there's so many packages are available. So you need not to start from scratch. And it also support advanced geospatial statistics and modeling and visualization also. So like plotting is very easy in R, and modeling also we can easily do in R. So it's very good for geospatial analysis. Next, it also supports interactive map making with the panel dedicated to interactive visualization. So that part also is like we can easily make maps using R. And it provides many statistical techniques such as statistical test, classification, clustering, and data reduction. These we can use for data analysis. So already inbuilt functions are there. Directly we can use these functions for clustering and classification or for regressions. Next, it provides a IDE that is called RStudio, which is very easy to use, and it's very popular also, and it has a like large community of supports. So you can get if you have any doubt, you can get you can search just on Google, and you can get all the solutions on Stack Overflow, or so many other websites are there. And its documentation is also very rich. So you can go to its website, and you will see all the functions, all the packages are explained very well. And it's also a object oriented programming, so you can directly map real world objects to R. And it also support functional programming also, so you can create functions for each and specific module. So modular, it will become, your code will become very modular. So R has so many benefits. That's why we should use R for geocomputation. I think earlier, in last session, Python also they've explained. That is also very popular for geocomputations. So both are very popular, R and Python. So how to download all these things? First, we need to download R. So R we can download through this website. as you can see, this website sran.r.project.org. Directly you go to there and you can download this latest version 4.1.1, which is stable version, and installation and other instructions also given. So I have already downloaded and installed for this session. So if you click here, one exe file will be downloaded directly, and it's very easy to install. Just you have to click next. So it's like very easy to install. Next part, you have to install R Studio. So basically it's a IDE like Eclipse, you may be aware, yeah, NetBeans, you may be aware of all these IDEs. It's like that only. So here you can go to this website rstudio.com, and here you can search for like so many versions are there. So you have to select RStudio desktop version. It's free, and you can download it, and it's easy to download, similar like to R, and you can install it just using next and next. So for this is for Windows, and for Linux, like suppose you want to install for Linux, Ubuntu, Fedora, OpenSUSE, they have also given. For Mac OS also they have given. So for like it's already I've explained in multi-platform. So for each available platforms they have given the exe or this software. So as already I've explained you through browser, these two websites are there. You can go there and you can download latest versions of R and R Studio. So installation part, same thing already I've explained you. And for Linux, you can directly use through command line, just sudo apt-get install R base core. So it will install the base version of current base version of R. So this will be installation procedure of R Studio, which already I've explained you. Next I will show you how these things look like. So I will go to, so here you can see this is R, and this is the command line, console line of R. So here easily you can type any command or any language specific of R, and it will get run here, like single line commands you can type here. Suppose I want to print hello. So just you have to type and print enter. So it has printed hello world. And suppose you want to do some calculation, like suppose you want to multiply something. So directly on command line you can use it as a calculator also. You can, suppose you want to calculate this power of this, so it is giving 8. So print also is not required, directly it will result, but specifically you, if you want, then you can use print also. So suppose you want to assign any variable value. So there are two ways, like suppose directly you can assign a is equal to 8, suppose I have assigned integer value. And if you want to see the class of a, this will tell like what is the type of a. So it will say numeric, okay, and this taken as a numeric value. And if you specify a is equal to suppose 8L, then it will be, I think it will print as integer. So it has taken for integer you have to specify L here. So these things I will explain later. So through an assignment also you can do like this also. Suppose you want to assign a to a, so the assignment you can use equal or this arrow, after that slash option, or you can do like this also. So these are three ways to assign a variable on like in R. So this is console, and all program you can compile here. You can like it is interpreter language, so line by line it will interpret. So directly you can run here also. Script directly you can R source code, or you can on console also, if you want to check anything you just write there and you can check there. So this is the basic data types in R. So in R there are 5 basic data type. First is numeric, which I already have told you. So it will be like a floating point number we call in C, same thing. So next one is integer. Integer you have to specify like a number, after that you have to give L. So L declares it, this is an integer. Next you can declare complex number also in R. So you have to specify the constant part and complex part, like 9 plus 3i. So where I will be the imaginary part. Character or string, just you have to give in double quote and it will treat as a string. And next is logical, that is also called boolean. It will have a true or false values. So I will give you demo of these things. So one more thing I wanted to tell you about this R notebook. Similar to Jupyter notebook for Python, in R Studio they have provided R notebook. So simply what you have to do, you have to go and select a new file here, like suppose R script is, this is R Studio. So in this R Studio it's ID, so you can write a script file, notebook, R markdown. So similar to Jupyter notebook, they have given this R notebook. So here what you have to do, you have to create a notebook and you can write your codes also, snippets of code. Along with that you can give descriptions also. So suppose this one I have written. So and this is suppose directly you can view these things on HTML or PDF or Word format. Just you have to click here. So I wanted to preview in HTML. So it is coming like this, same thing. So along with coding you can do documentation, similar to, it's very similar to Jupyter notebook things. So that markdown, some syntax is there, like suppose first you have to specify title, and in title it will come as like here you can see heading part, and output also will be have to specify whether HTML, PDF and Word, three formats you can see the outputs. So these things you have to specify, like setting you have to specify, like here I have given default, but in other file it's need not to be default. So suppose here I have given here I have specified some sections, like number of sections, TOC. So it's up to you. You have to just go through their cheat sheet. It's very easy, and you can implement these things easily. So what is the major benefit? Like directly you can write the code and you can convert it into documents or HTML web page. Directly it is visible like in HTML web page or in documentation, PDF or Word format. From here you can see like you can convert it to HTML, PDF and Word. So no need to do separate documentation. That is the major benefit. And you can write detailed in a like comment, like each function what it is doing. So that is the major benefit. So I was explaining you basic data type of R. So suppose you want, so already R is installed. Suppose you want to check the version of R. So just you have to give r.version and it will print the version, like platform it will print. So it is Windows platform and it is 64-bit, and background compiler is MinGW32, and the major version is 4 and minor version in 1.1. So already I have told you, here I have shown you this recent version of 4.1.1. This only I have installed. So you can also install it. Next, this thing already it is similar to like console only. Suppose you have given hello world and you want to run. So from here you can run, and it has printed hello world. So if you want to specify print also, then that is also possible. Just you have to write print, and whatever you want to print, that also is possible. So like this, it is this function is like similar to Python. Like just you have to write the name of variable and it will give the value if you are running it. And this is a interpreted language, so it will interpret line by line. So that is also one good thing. So basic data type I was explaining. So these are basic data type, already I have told you. So suppose you have given a numeric value you want to declare. So here I have declared x and I have assigned it to 10.5. So it's a floating point number, so class should come as numeric. So suppose I am running it, so this is the numeric thing, it is coming because class of this variable is numeric. Next is integer. For integer you have to specify L along with the value. So in this x variable I am assigning 1000 and L specify that this is a integer. So this class of x will be printed as integer. So if we run this, it will come as integer. So as I already told you, complex number also you can specify in R. So suppose I have assigned 9i plus 3 to this variable called x, so it will print as a complex. Next is you want to specify string. String also you can specify. The class of this variable will be printed as a string. So suppose we run this, then you can see it is printing as character. So character or string, same thing. Next is logical or boolean. So it will print true or false. So suppose we have assigned x true value, so class of x should be printed as boolean. So this is a logical or boolean, same thing. So suppose you want to print the value of x, just specify s and it will print x also. So x value of x is true and its type is logical. Suppose you are giving false, sorry, all are in caps actually. So it is giving x as a false. So these are the basic data type in R. Next we will move to like what are data structures in R. So one major thing is a help function. So suppose you are not aware of anything, help function is very useful. So all the functions are documented with the help page and you can access using help function. So suppose you want to check help for print. So you just have to type this help and print. So here it has come, like it will description is given and how to use it, all the things has given. So it's very good. Directly you can see like how to use it. Shortcut also is there, no need to write help, just you put question mark and write print. So that also gives same thing only. So it will give print values and how to use this function. So this is very useful. So we can use it for like if you have any doubt regarding any function, what arguments it will take, so you can use help function. So next is like what are the data structures in R. So vector is there. So vector is nothing like a 1D array of C or 2D array of C. So you can specify vector. After that matrix is there. So matrix is a 2D vector. And array is a multi-dimensional matrix. So in matrix you can only specify 2D, but in array you can specify more than 2 dimensions. The next is data frame. So in data frame we are a tabular type of format of data. In this we'll make a tabular format and like the .csv or anything, and we try to read it and we try to use it for plotting or for any analysis we can use it. And next is last one is list. So list is like a collection of data and it can be different type of data. Like in vector it should be same type of data, but in list it can be different type of data. Generally vector list is implemented using linked list and vector is implemented using array. So I will show you how to use all these things. So suppose this vector I am creating, vector of strings. So C is for concatenation. So suppose you want to concatenate all these things into array, so you have to use C. After that you have to assign these whatever the input you want to give. Suppose here I have given banana, apple and orange. So this vector has been created. So I will run this code. So this will printed as a vector 1, and vector 1 it has contains banana, apple and oranges. So this is a vector of a string. Similar way you can create a vector of numerical values also, and integer also. Suppose this code I am creating a numerical values array vector. So here 1 2 3, okay, and here like in a sequence you want to create, that also you can create. So I have created from 1 to 10. It's a sequence, it is increasing by 1 at a time. So value will be like from 1 to 10, and it will be a vector type. Next one is like suppose you want to access any particular value. So suppose here I have created vector 1. So I suppose I want to access the first element. So in other programming languages generally index starts from 0, but in R it starts from 1. So suppose you want to access this one, so you have to type 1. So it will print banana. Suppose you want to access I have assigned this vector 1, and second element you want to suppose access. So just to give this, and if I am running this, it will print first element, then second element. So this is the most important part. Like in other programming languages generally index starts from 0, like in C or C++, but here it starts from 1. Similar way we can assign a we can make a list also. So list can be like different data types in a single list. So suppose I am creating here a list of strings. It can contain different data type also. So this list I am making, and for making list you have to use this function called list. So it contains all same thing only. So suppose you print. So this is the difference, like there only one vector was there. Here in list it is printed as a list. It can contains different data type also. Here also suppose you want to access the first element, so you have to specify the list. After that in column you have to give index of that one. Here also index start with 1. So it will print apple. And if you want to change a particular item in the list, so you have to give the, like suppose list name and index of that list. Suppose here we want to change it from apple to mango, so we just give the index and we can assign mango here. So this has changed the list to mango, banana and cherry. Next data structure is matrix. So matrix is very important data structure in R. It's a two-dimensional data set with column and row. So suppose you want to create a matrix, you have to specify a number of rows and number of columns along with the values. So suppose I am creating a, and the function for creating a matrix is matrix. So suppose here I have given this, I am creating a collection of numbers from 1 to 6, and number of rows I am giving 3, and number of column I am giving 2. So it will create a matrix of 3 rows and 2 columns, and values will be like 1 2 3 4 and 5 6. So after running this, yeah, this matrix has been created. Next part is array. Array is similar to matrix, but it is more than 2 dimensions. So here dimensions should be more than 2, then it is called array in R. So other programming language may not follow same thing, but here in R it is called array if it is dimensions are more than 2. So for this also we use a function called array, and here also we have to specify dimension. So for this, suppose first I have created a 1D array which contains the value from 1 to 24, and after that from this array I am converting it to multi-dimensional, like 3-dimensional array. So like 4 column will be there and 3 rows will be there, and 2 set of matrices will be like it's 3-dimensional matrix. So suppose I am running this. So this is 1D matrix I have created through this code from 1 to 24. So these values are there, and next what I am doing, I am converting it into 4 cross 3 and 2, like it will be a 3D matrix. So here first set and next one is second set. So this is array, and next is data frame. Data frame also is very important data structure. So all the data to store in tabular format, we use data frame. So suppose here I've created one data frame. In this I am creating three columns. So first one is training, next is pulse, third one is duration. So in each column I have to specify the values for all threes. So suppose if I run this, then it will print like this. So it has created a data set. It is having three columns and three rows. So and column and rows name be like, column name is be like this, whatever I have assigned, like training, pulse and durations, and values will be all we have given, will be assigned to row wise. So one more program is there on data frame. So suppose I want to create a data frame, and after that I want to add one row or any column, that also we can do. So here what I am doing, I am creating a data frame using the values rank I have assigned 1 to 3, from 1 to 3. After that I computer name I have assigned, suppose Hussein is there, Tyson and Johan. And after that I have assigned the like mark will be like all these persons. For individual I have assigned a mark for all these. So for using this we can create a data frame. So all these three I have taken, rank, computer and mark, and combined it using this called function called data frame, and assigned to athletics. So suppose I am running this. So if you run this athletics part, so here it is showing the values. So it has created a data frame having 3 rows and 3 columns. And suppose you want to add a row to this data frame, so simply you have to use R bind, and you have to give the name of your data frame, and after that you have to give the value, the new value whatever you want to assign. So I've given one more row I've added here with rank 4, computer name and mark. So suppose we run this. So now you can see here fourth row is added. Suppose you want to add a column also. For that they have given cbind function, and using this you can add a column to this same data frame. So I will run this. So here you can see one more column added called nationality. From here I given name, nationality, and after that values for each rows. So this is a like a very important data structure. We can use it for data analysis, geospatial analysis also. And suppose you want to print a subset of a data with which followed some conditions. Like suppose I am giving a mark is less than 9.96, that athletes only I want to print. So for that they have given one function called subset. So suppose if you run this, so sorry, fully you have to run just selected part. If you selecting something, so that selected part only it will run. So here you can see all the athletes which has marks less than 9.69 has been printed. Only 2 are there, Hussein and Johan. So that's why 2 has been printed. Suppose you want to check help for these functions, so just type R bind. So here you can see C bind, and after that it will later on R bind, like these are both similar only. So they have given this documentation for how to use this, all these things here, a number of arguments this function takes, that also you can see here. So its documentation is very good. Any function you have any doubt, you can just type help and function name, otherwise a question mark and that function name. So this is how data frame is constructed in R. So next part is after data frame we'll move to conditional. So in conditional is similar to other languages, like if else is there, and nested if else will be there. So it is similar to like C++ or Python. So just you have to type if, after that you have to give your expression, after that a statement that will execute it if it is true, and after that else will be there. In else case, if that statement is false, then else statement will be executed. You can assign like else if also. It is similar to C, so that I think you may be familiar with that. So anyway, I will run one snippet of code. So here suppose I am assign R to a, and suppose in this R studio code I am assigning a to 33, and for B I am assigning 200. So here B is greater than A, so this condition is true, so this statement should be printed. So suppose I am running this, so first statement is getting printed, B is greater than A. So this is a conditional expression in. Suppose you want to add any one more condition, else if, and condition expression, suppose A is equal to B, then what you want to do. So that also you can add here simply. It is similar to like C, so same syntax only it follows. After that loop, so loop you can do loop in R using for loop or while loop. So here I have written one snippet of program. So this in this what I am doing, I am assigning R a value I, which will be run from 1 to 5, and here I am incrementing it by 1 and printing this. So suppose if we run this, so it will print values like 2, 3, 4, 5, 6. So I am starting from 1, but here I am adding it to 1, that's why it will start printing 2, 3, 4, 5, 6. And same way while loop is also there in R. So for while loop, you have to give one conditional expression. So if that conditional expression is true, then it will be executed. If it is false, then it will not executed. So suppose I is less or equal to 4. If it is true, I is less than 4, then it will be printed. This will go inside the inside the code. Otherwise, it will not go. So I have assigned I 0, then I am printing, so it will print from like here also I am doing I plus 1, so it will print from 2 till like 5. After that it will stop. So here you can see like 1, 2, 3, 4, 5, 6. So first 0 has come. 0 in this case it is not like I is less or equal to 4. Yeah, it is less, so it is true. So it is going inside and it is printing. So this is how you can run while and for loop. So it is similar to C only. If you are familiar with any programming language, it is similar to that. Next we will move to plotting part. So for plotting in R they have given plot functions. So suppose you directly you want to plot 2 points. One this is X part, this is Y part, and this is the 3 and 10. So suppose you want to plot it, just you have to run this and it will print plot. So here value 1 8, and next one is like second point is here. So it is plotting that points. So in the similar way, using plot function you can plot line also. So for line, what I am doing here, suppose you want to plot a line, so just you have to give type 1. So many dot for dotted type 0 is there default, so that's why here I have not assigned anything. And if here I will assign type 1, then it will form a line. So in this case, suppose from 1 to 10 we are printing and we are giving type 1, so it will give a line. And suppose and if you want to print multiple lines plot, so line 1 I have created, line 2 I have created. First I am plotting line 1 here, so I will run this code. Yeah, you can see I plotted line 1. So in line 1 I am giving color blue here, and because type I have given 1, from 0 to 6 types are there, like dotted will be there, bold will be there, and points will be there. So for that from 0 to 6 will be there, so that you can go in documentation of plot and you can find that. For line, type will be 1. So first I plotted this first line, line 1, from like these value 1 2 3 to 10. After that I am plotting this line 2. So for line 2, what I am doing, I am using lines. So you want to plot multiple lines, so you have to use function called lines. So in this it will by default take like line 1, and line 2 I have given. After that type 1, and color will be red. So this will be plotted here, you can see. So suppose you want to plot a scatter plots. So for that, this simply you have to give x and y1, and second data set I have created x2 y2, and after that I am plotting x1 y1, and next is I am giving points on the same plots, so x2 y2, and that will be, second will be in color blue. So if I run this, so it will come as a scattered plot. So this main will be the heading of that plot, and x and y you can assign, like x axis will be written as a car age, and y car speed. After that, color, for first one I have assigned color 1, line this one, and for second one I have assigned blue. So these points printed in blue color. So you can draw pie chart also using R. So it's very easy. So suppose in one variable I have created x. In this I have given 10, 20, 20, 50, and I want to make a pie chart of this. So just you give pie function, and after that variable name. Suppose I run this, it will come as this. So fourth one is 50, and first one is 10. So it has assigned accordingly. You can create bar chart also using pi. It's very easy. So suppose you have created one variable a b c d, and these are the frequency of these that will be printed in like that will be a frequency that will be in y axis. So just simply you have to give bar plot y, and after that name you have to assign. So these x name.arg I have given x. So this will so nice like this. So this bar plot or histogram will be very easy to draw on R. So, and after that there are so many data sets available on R. So like you can if you want to use or analyze, or you want to learn things, no need to create your own data set. Already so many data sets are available on R by default. So they have one data set called empty car, this one IIRS, and after that tooth growth. This is like vitamins, and this also have collected the data, effect of vitamin C on tooth growth, and plant growth also they have collected, like how plant grows. So these are the default data set already available in R. So this empty cars, it is a motor trend car road test which is retrieved from 1974 magazine. So this is already available in R. So suppose you want to know anything about this, so similar way like help function, you can just like use this. You can see search this, and this will give all the documentation related to these data sets. So empty cars, suppose this is giving motor trend car road test. So description also it has given. Similar way you want to suppose know about IRS, what this represent. So just you have to give, and this has given IRS dataset. It is a very famous dataset of flowers collected by Fisher Anderson. So this is a very popular dataset for which is used in machine learning and data analysis. Similar way, these are also available, tooth growth and plant growth. So suppose you want to load some dataset which is already available. So here what I am doing, I am just creating a variable data cars, and I am assigning all these empty cars values to this data cars. And now after that I am printing head. Head is like in Linux. Suppose you want to print the first few lines of a file, so that it is similar to that Linux command head. So if I run this, so it is printing starting few lines of that data set. So here these are the columns, and here these are the models which has these values. So suppose you want to print the from end, so you can use tail. So this way you can print the last from end in the data sets. So suppose you want, these are the columns. Suppose you want to get the max and mean of this HP column. So simply you have to just give max. You have to use max function, and inside that you have to give your variable data cars, and after that dollar and column name. So column name is HP. So I've given here HP, and this is my variable name. For mean also same thing. So it is printing the mean and max of this data set, and having in HP column. So in HP column, this is the max and mean data sets. Similar way you can derive median and mean also. So mean, you can just use these functions already inbuilt in R, mean and median, and you just give your variable and column name. So it will print mean and median for those data sets. One more important thing, they have given percentile. So directly how many datas are within the value that given a percent of lower than, like suppose 75% are lower than this value and 25% are lower than this. So percentile, you can just give the data name and variable name, and after that column number, and you just use this function called quantile. So suppose I want to use, so they have given like 0%, 25% data sets, and 50 percentile, 75 percentile, 100 percentile. These are inbuilt function and very useful for statistical analysis. Similar way, IRIS dataset is also there. So suppose we want to print this head of IRIS dataset, so it contains all these informations, and you can print number of columns also. Suppose you want to print the number of columns for this IRIS dataset. How many columns it contains? So it contains 5 columns. And similarly, you can print row also, number of row for any data set. Just use function nrow. So 150 rows are there in this data set. And one more useful function, they have given summary. It will give all the mean, max, median, mean. So just you have to type summary and give the data set name. So suppose here this mean, max, for each column they are giving first quantiles like this. Summary, full summary they have given: first quantile, third quantile, median, mean, max. So it's very useful function. Similar to plot, one more package is there that is very good for visualization. It is called ggplot. So suppose you want to plot this IRIS data set using this ggplot. So first you have to install these packages. To install any packages, you have to just type install packages and package name. So already I have installed this. If you want to install, just type this and it will install. So it's double colon and package name. So this will install ggplot2 package. So it's very useful package for data visualization. So suppose if directly I am plotting this IRIS data using plot function. So it is printing like something this. So it's very tough to make out what all these things. So for visualization using ggplots, it's very easy. Plot is also very good, but ggplot is better for visualization. So here what I am doing, I am taking this. It has these columns over there. So we are taking this special length as x and special width as y, and we are trying to make a graph. So using ggplot we can do that. So ggplot is like layer based. You can just use this plus and you can add as many layer as you want. So here suppose what I have done, first I have written this ggplot. After that I have added one geom point layer in which I am specifying asses, axis, and after that I am specifying X and GZ title. So these layers you can add as many layer as you can add in ggplot. That's why it's very easy to use. So suppose I am running this snippet of code, so it is coming something like this. So these are species are there, these many, and these are the variations like special width and special length. So easily we can make out like what are the ratio between these like species wise, like which has more length, which has more width. So these were the basic introduction of R. So now we'll move to geospatial analysis using R. So this part I already have covered, loops and function. One more thing I have to describe function in R. So like similar to, it is similar to like C. You have to just give the function name and after that argument, and you can easily call that functions. So that I will also explain you. So here I have created a function Fibonacci series. Here I have created one function in Fibonacci series, very popular. It's very popular series in computer science. So here what there I am doing, I am creating one function called Fibo, and I am passing a argument like till what number you want to Fibonacci series. So first variable will I am giving 0. After that second variable 2, and next onwards third variable it should be like fn is equal to fn minus 1 and plus fn minus 2. So for first 0 is 0, after that 1 is 1, after that next will be 1, next will be 1 plus 1 2, like that it will vary. This is called Fibonacci series. So for 5, suppose I am printing this Fibonacci series, so first I have to compile run this. So this function has been added to data global environment. Now I can call like for 5, suppose I am calling. So it has printed for like till 5 numbers Fibonacci series. So it will start from 0 and will go till 1. So suppose for 7 I want to print the Fibonacci series. So this is the Fibonacci for 7. Next number will be the addition of previous 2 number. So function is also very similar to C in R. So for this geospatial analysis in R, we need some packages like suppose raster package, rgdal package, sf package. So we'll install these packages and we'll try to use those packages. So ggplot already I've explained you. So sf is stands for simple features. It's a standardized way to encode special vector data. It is for vector data only and it is not used for raster data. And it is like superseding these GDAL and SP packages. So I will show you how to use this SF package. So here in this I have created one notebook for this, our notebook, and first we'll install this SF package using this command called install packages SF, and if any dependency is there you can make it true, so it will install all the packages which are dependent for which SF is required. So these packages it will get installed here. So already I have installed, that's why I have commented. So you can start from this installation part. After that you have to load these libraries. After installing these libraries will be required for vector analysis. So I will run this. So these libraries got loaded. After that you have to read the data file. So I have I have used one district.go save file here, which is a vector file and in this it contains the districts of Uttarakhand. So you have to read this save file using read sf function. So it's very easy using a sf library. Just you have to read sf and the file name you have to call. So now this file got loaded, and suppose I want to plot this data. So this is the data, area is there, perimeter is there, district is there, district 1 and district. So these are the data in my save file I can show you data also. So this is the metadata of that data. It has like polygon type, geometry type, dimension is in x, y, x mean and x max. After that, data is there in data tabular format. So area is there, perimeter is there, district is there, district again. After that, geometry is polygon. So if I want to try to plot this, this will come as this. So all data got plotted here. So suppose same way, if you want to print the like first few lines of this data save file, so it will give the first starting few lines of this save file. Using head command you can print it. After that, if you want to know like data type of this data frame which you have loaded from save file, so you can use class function for that. Similar we have used in like basic data types, so to get the class of each type. So here also you can use. So if I am running, so it is coming SF, after that tabular format and data frame. So data frame is nothing but it's like whatever the attributes are there, and is SF because it's a save file and its geometry is polygon. If you want to know the what are the coordinate system it is using, so simply you use the function stcrs and it will give the coordinate reference system for this data set. So in this it has been not specified in this file. So it is using 8824, but when you are writing this save file you should specify, then here it will come. And suppose you want to convert it to any different reference system, that also is possible. So suppose I want to convert this format from 8824 to 338. So I am taking one new variable UK district 338, and in this I am assigning all the data of UK district which I have taken from this save file. So I will use this st transform function. In this you have to just specify the coordinate system and it will transform this data to that particular format. So I have taken this format and I am specifying 338, so it will convert this data to 338 format. So it has been. Now if you see the CRS of this coordinate reference system, so here you can see input is in 338 format. So for converting that, st transform function is given by this sf package. So to and reference system now it is printing as 338. Next, suppose you want to like see like how it is different from this. So I will plot this this and old data also I will plot. So this is our old data which is in 883 format, and this is our new data which we have converted into 338 format. So you can easily see like how it is different from that using this plot function. And you can also get this number of column, number of rows, like attributes of each data. So like you in UK district, how many columns are there? So total 6 columns are there. From head you can see like here 1 2 3 4 5, and like polygons will be there. So total 6 numbering will be there. So total 6 columns are there. Next, suppose you want to know number of the rows. So number of rows also it will print. So total 13 rows are there in this. So I think it's a district map. So total 13 districts are there in Uttarakhand. So that's why number of columns are 13. After that, suppose you want to summary of that data, similar to whatever I have already shown for like IRIS dataset. So it will give summary of for these all this like mean, first quantile, median, mean, third quantile, and max values. And like shape will be polygon, and number of rows is 13. So these things you can see in summary also. And if suppose you want to filter any data, suppose I want to filter like area should be greater than 4.4 into 10 to power 8, So just you use the function filter, and you give the column name area, and it should be greater than this value. So here only those columns are there which are greater than 4.4 10 to the power 8 are equal to. So this, that's why these only 5s are there. Total the 13 row are there, but only 5 are printed because these districts has area more than 4.4 into 10 to the power 8. So these many things you can, there are like these many things you can do using SF packages. There are so many other functions also, but I am covering the basics. Now we'll move to raster data analysis. Victor we have covered using SF. So for raster we use package called raster. So similar way, first you have to install these packages. Install packages, and you have to assign the package name raster, and it will be installed. But already I have installed, so if you are doing this, you can do this. So first I will, as I already explained you, raster data can have multi-bands. First I will try to use single band, then I will move to multi-band data. So what here I am doing, so my file is in this directory, desktop geoanalysis using our raster data. So I am setting my working directory to that. For that there is a function called set wd. In this you have to give your directory name where your files are there. So I am setting this to that working directory. So my current working directory will become like now this, and if I have to run this. So for raster data analysis we need all these packages. So now in latest version of R, this RZDL and SP, in place of these now SF is getting used, but still for some function it is required, but in future SF is recommended for that analysis in place of SP and RZDL. So you need to load these libraries if you have installed it. Otherwise you have to do package install.package and raster, and similar way SP and RGDL. And I have loaded all these library now, so I will run this. So here you can see whatever you are running there, here it will be shown, like these commands executed. If any error is there, here it will be printed like this error is there. So this is the forest fire data of Uttarakhand on 19th April that I am taking. So here what it is representing, it will be representing like chances of fire, like probability of fire. It is characterized into from 1 to 5. Suppose the area which is very less chances there to get fire, it will be categorized as 1, and other will be categorized as if it has a high chance of getting fire, so it will categorize as 5. So basically it is representing like chances of getting fired of particular region, this file. So I have specified this file name here in this variable. After that you have to use this raster function to open this file in a specific object called dem. Dem object is created by R for like elevation modeling. Same object we are using for this fire analysis. So in this dem object we have opening this file forest fire danger map on 19th April.tif. So we will run this. Okay, sorry. So now I will run this. So you can see now the data of this. Suppose I'm, so this is the metadata of this file. So it is a raster layer, and dimension like number of pixels will be there, number of rows, number of columns will be there. After that total number of cells will be there in this grid file. After that resolution is there. So for each cell having resolution 89.99, 89.99, each cell having resolution of this. After that extent of this map will be there, and next the projection system will be there, if coordinate reference system. After that source is same thing, and name is like what is the file name. And now it doesn't contains the cell max or min value by default. For that we have to use max and min function. So currently it is taking from 0 to 255, any value it can take, but we need what we have assigned from 1 to 5. So for that you need set min max function. So in this you have to pass your data frame. So if I am running this line, so it has run. Now if you see, min max value will be getting changed to 0 to 5, because already I have told you it contains values from 0 to 5. So for that you have to use set min max function. So if you want to view the coordinate reference system, just data this variable name, after that at the rate CRS. So CRS will print the coordinate reference system. If you want to see the extent individually, you can see overall here also it is giving same thing, extent CRS. So suppose you want to make a histogram of all the values in available cells. So for that you can use hist function. Here you have to give the your data. After that you have to color, you have to specify, and maximum how many pixels you are giving. So here total these many pixels are there. So for in bit here I have assigned like these many you can give. Maximum you have to assign, so that it should not create a problem on memory. So you can see here distribution of values has been created from 0 to 5, and for each it is giving the frequency of occurrence of these numbers in each cells. So so max having zeros, after that 1 is there, and 3 and 4, 2 also little bit. So this is the value it in the file contains. So I will plot this DM map, so you can easily see like how it is distributed. So you can see here, so from 0 to 5 values are there, and each value has been assigned a particular color. You can specify your own color also. Like here I am giving like next part 5 colors I am assigning, and I am breaking like from here it has been break into 0 to 5, but here I am breaking from 2 3, after that 5. Only these 3 values will be there, rather than from 0 1 2 3 4 5. And then I am plotting this. Suppose I want to run this. So you can see like from 0 to 1 it has given single color, after that 2 to 3 one color, and 3 to 5 one color. It has been breaked into 3 parts. So these things you can do using break functions, break variable, and this number of colors, terrain color I have assigned 5. So many values are there that you can assign, so like arguments are there for plot, that you can see in help, using help, or you can use Google for that, whatever is applicable to you. So generally this plot function doesn't print more than 1 lakh pixels. So for that we use image functions, which is also given by R. So suppose if you run this, then it will the whole image part it will give, it will be load the whole image rather than just 1 lakh pixels. After that you can perform maths also, like suppose all the values each cell having 0 to 5, you want to multiply it by 2. So math operation you can also perform. So I will run this, and now I will plot this new variable which I have obtained using each value we have been multiplied by 2. So you can see earlier it was 0 to 5, now it is been multiplied by 2, so each value has been increased, so from 0 to 10. You can do crop also, masking also, using crop and mask functions. So simple crop I will show here. Suppose I want to crop a particular part from this source file. So first I will plot this file, and I want to crop particular. So this TIFF file has been plotted here. So I want to crop a particular region. So for that, draw extent function is there. So using this function, you can click on this map and that part will be cropped. So this part I have cropped from here. So now I am assigning this crop part to a new variable called dem crop 1. So for that we'll use crop functions here, crop and your crop box and your old data set. So this dem crop will contains only these parts. We can show it by drawing it. So we'll use plot function. Just 1 minute. Yeah, it is showing that part only now. Now, like it has values from 1 to 4. That particular extent of that particular cropped image of that file. So you can use mask also and crop also. So these many functions are there. You can use basic maths also on raster files for geo computation. So next I will move to multiband data. So for multiband also you need same libraries only, which already I explained you, raster, SP and RGDAL. So here I am taking a map of Dehradun in which three bands are there. Red band, RGB is there. So it is a satellite image and it is representing the reflection of each colors. So this file I am taking. So I will run this code. So by default, if you want to read, similar way here we have read in single band, raster, and after that this paste, and after that this working directory and file name you have to give. Same way, if you by default in multi-band, it will read the first band. So if you are not specifying any band or anything, it will read the first band. So suppose I want to see the so you can see this is the band 1 of 3. By default it will take first band, and if you are specifying band, it will take that band, that particular band. So in this data frame I am taking band 2 value. So suppose if I run this and I am running this, so here you can see it is simply giving the band 2 of all three bands. So same way you can whichever band you are interested, you can take that band, or you can use stack function also. That is also possible to it will create a array and it will store index wise, like for 0 it will store first band and second band and third band onwards. So suppose I want to load band 2 and I want to plot it here. So I've loaded here, I want to plot it here. So it has been plotted. So it is showing the band 2 data of this Dehradun district of Uttarakhand, and that reflection in band 2, and it contains values from 0 to 250 each cell. Next, suppose same way we can upload band 3 data also. Now you can see it is giving band 3 of 3 bands, and here also you can see dimension of that, resolution, extent, same way like I have shown you in the single band raster file. So to load in a single data frame all three, we use stack function. So in this, just you have to give the file like working directory and file name, and it will stack all the three bands in a single data frame. So now you can see so it is giving raster stack, and all three bands are there. Number of rows, number of column, total number of cells is there, and number of layers, that is band only, all three are there, and mean max values also are there. So for all three it is giving. Now you want layer specific information, like I printed for raster band 3, band 2. So for that you can use layer attributes. So just you have to give the data frame, after that at the rate layers. So in stack variable I have taken from this stack function, so at the rate layers, so it will print for all three layers. So you can see here it is printed for 1, after that for second band, after that for third band. Suppose you want to view a specific attribute for any single band, like suppose for first band you want to view. So in stack at first index, first band will be stored, similar second band will be stored. Suppose I want to see the second, for second band what are the attributes. So you can see here just it's printed the attributes of second band. After that you can make histogram also for all this, like in single function using histogram you can make histogram for all three bands. You have to give this RGB stack data frame here. So you can see for first band it has created a histogram, for second band also it has created a histogram, for third band also it has created the histogram. So in first band you can see like all values generally extending from 50 to 150, major values are lying between 50 to 100. And in the second band also you can see like values are going from 50 to 150, but this centroid of that is shifted towards here it is around 50, but it's shifted from 50 in band 2. So it contains different values, all of those values. You can plot also all these three bands. So suppose I want to plot all these three bands, so you can just use this plot function and you can give the data frame which you have got from stack. So it has printed plotted all the bands, first band, second band and third band. So this way you can process multi-band or single band data in R, and you can perform all the operations, mathematical operation, computation in R. So but there are few disadvantages of using R, like I will show you. So its memory management is very poor in R. So like suppose if you are loading raster data, and raster data generally size will be very huge, so it will not the processing will be very slow. So for that R has provided one function called aggregate. So it will be aggregate multiple cells into a single cell. You can specify the level of that aggregation. Next is its speed is very slow compared to Python or C++. Speed of R is slow, and security is also very poor in R. For like suppose you want to publish anything on web using R, so it's very poor in R compared to other languages. And because it's open source and huge developer community is there, so quality of some packages are very poor, and there is no standardization. So you have to create your own standardization for coding so that it can be followed through the organizations. So these are the major disadvantages of R. But anyhow, it's very powerful language for performing geospatial analysis. So that's from my side. If you have any doubts, you can ask. I will take a break and I will answer that.